Hello and welcome to another stream about Azure Kubernetes Service, building it using Pulumi and C#, .NET, all of the good stuff. So we're going to have a look this week at creating a private Azure Kubernetes Service cluster. That means greater security, means your cluster is not exposed to the internet, which could lead to all kinds of bad things. Azure has been known to have leaks in the past. So definitely something that we should all take into consideration, and I think private clusters should be the default that everyone should go with. It does require a bit more work on the part of the developer setting up the cluster. So we're going to have a look at that now, and we're going to dig right in. So let's make a start. So just a quick catch up about previous live stream. I redid all of the configuration code. So now the configuration is using all kind of a nested hierarchy of YAML. So all our Kubernetes settings are listed in this section down here. So we've got our maintenance schedule, our core Kubernetes settings over here, which SKU we're using, how we want to upgrade our nodes, and then the node pool settings is just an array now. So you can choose the type. System node pool means there's no user node containers running on this node pool. User means there are, and spot means that it's taking advantage of the cheaper spot prices for Azure virtual machines. So you can now create multiple system nodes, and you might want to do that just in case you want to choose a different VM size, for example. So that's a possibility now. And then you can also specify multiple availability zones. So you probably want in production 3 availability zones here, and 3 also in the user node pool. And then the maximum node pool count I've used here is just 1 for the system node pool and 1 for the user node pool. In the real life, in production, you'd probably want a minimum of 3 of each of these. And you probably don't want to use the standard B2S virtual machine either. I also added validation. So I used Fluent validation. If you look at my last live stream, you can jump right in, and I cover how to use Fluent validation in this kind of real life scenario where we validate pretty much all of the different types of things that can be validated in Fluent validation. So it's a very good example of how to use that library, and highly recommended as well. Makes it very easy to use. That meant that we were now able to new up our configuration, new up our validator, validate it, and if it's invalid, the YAML is invalid, we get a nice error message now from this line of code. So that's all good. Let's dig into private clusters really quick. So to get started on a private cluster, we need to go and jump into our Kubernetes resource. And there's this thing called API Server Access Profile. API Server Access Profile. This is on the Kubernetes Managed Cluster Arguments. And I think we can just, I've got this note here. I think we can just set this, but you do get an error here. No, that's because there's some APIs which are not supported in the stable version of Azure. Ajmal is asking, is AKS supporting size upgrade? I didn't see it working. Yes, so you can upgrade the size. There is a caveat with that though. So if you upgrade the node count to say 3 nodes, and then it will auto scale from between 1 and 3 nodes, and you can do the same here with the system node pool. But I found that you cannot then upgrade the availability zones. So if you did this and you did say 2 nodes here, what this is going to do is create between 1 and 2 nodes in each availability zone here. and then the same goes for the system node pool. But if you add availability zones, if you deploy, say availability zone 1, then add 2 and 3 and deploy again, it will fail. You will have to tear down the cluster and redeploy. And I think that's not Pulumi. That's a limitation of Azure itself. So the way to fix this guy is we need to upgrade to a newer version of the cluster API. And this is the first time we're having to do this. So let's kind of dig in around that. So we're using this namespace here. And if you dot on to the end of this, you can go and use an updated version of this API. So we want 2020, it's kind of hard to read, 2022-01-01, I think is the latest version. We don't want the preview. I think if we use that, if we upgrade this and this, I believe that will work. Is it? Yes, like this. Okay, so now the problem is that we have other types elsewhere that are also using that namespace. So we need to plug that in a few places. So anywhere else over here, and the day, I think it's in this cluster maintenance, cancel. Ajmal is saying he meant VM size. I think I haven't tried that, so I'll try it and we'll have a go and see if that has any effect. Where's the day gone? Is it in here? Yes. You want to add that there, and I think there's one more location, internal mode. This guy needs to have that new namespace as well, and now we are, I think, fully upgraded, almost. Oh, I had the full namespace in here, so I need to upgrade those as well. And I think I probably have the same thing here as well, just because I had an enum type that I think had a very similar name. So we got those sorted out. All right, cool. We can go back now to our Kubernetes resource, and now we should be able to notice, if we scroll up, that our API server access profile doesn't have the red line anymore. So what this does is this first line enables the private cluster. So the Kubernetes system nodes themselves, they don't expose their Kubernetes API to the internet. Then there is a setting that I need to kind of remind myself about. So so by default, there are a few different ways of exposing your private Kubernetes cluster. The first way, I think the best way, I watched a few videos on this, probably the best way, and I watched this particular video. If I can just find this, highly recommend private AKS DNS options. Private Azure Kubernetes Service DNS options by Gert Bake. I'm hoping I'm pronouncing that name correctly. What you can do is expose the private IP address to the internet. So if you want to access it, you have obviously it's a private IP address, so you won't be able to get access to the internals of the cluster. What you'll have to do though is then remote into a machine within the virtual network and then use that private IP address to gain access. So private this is what this line here is doing, is saying, I want you to give a public DNS name pointing at the private IP address inside the virtual network. So that's that bit of code. Once you've done that though, if we deploy our cluster now, we will find, and I've already deployed this, so hopefully it should be a bit quicker this time around, is that we will no longer be able to log in to the cluster and run commands externally. And what we'll have to do if we want to run a command, there's a few different ways of doing this, but the quickest and easiest way is to run a command that looks a bit like this. So you're running AZ AKS command invoke. You give it the resource group where the AKS cluster is, the name of it, and then you can run your Kubernetes command kubectl get nodes. So that is the quickest and easiest way to gain access to your cluster again, because obviously it doesn't have a public IP address anymore. You can't just talk to it over the internet. So it does make life a little bit difficult. Let's see how this deployment is going. So that's the first way. The second way that we can gain access to our cluster is by creating a new virtual machine inside the virtual network that we've created. And I'm going to draw a quick diagram for that. So we'll just pick the paintbrush and install when I exit. Okay, so this is our virtual network, VNet, and like kind of everything outside of it is the public internet. So if we want to, we have our Kubernetes cluster with we're living inside the VNet here, and in actual fact there's a subnet around that as well, but I'm gonna leave that out. If we want to penetrate the VNet and get to the now private cluster, we need to and then this is going to be over an internal IP address, so like 10.0.0.5 or something. Then what we need to do is first of all know what this IP address is, and the way we can do that is that this first setting, enable private cluster public FQDN, gives us the public address of the Kubernetes cluster. So it gives us a DNS name. So we can then use that DNS name pointed at the private IP, but then that will not penetrate the VNet because it's pointing to a private IP. So what we have to do, we have to put another virtual machine, and we have to remote into this instead. So we want to go, well, undo that. We want to go in here, and then we want to use this DNS name, which I will show you in a moment, to access the cluster. So this kind of just goes away. But even this is not right. There is a service in Azure called Azure Bastion, and that lives, let's say, outside the VNet. And what you really want to do is connect to the VM via Azure Bastion. And what that does is it makes sure it allows you, your VM, to be private. So this is not exposed to the internet either. And it kind of opens up all the ports and everything necessary to connect to your VM and make it really easy to do that. And that way your Kubernetes cluster is fully secure. So poor diagram there, but I think that gets the point across. So it looks like changing enable private cluster is not allowed. It can only be set while creating the cluster. So that looks like we need to tear down the cluster, unfortunately. So I'm going to quickly do that. But this is going to be our default setting now. So going forward, we're not going to have to do this again. So while that's tearing down, we'll look into, we'll tear that down there, and that will take a moment. We'll have a look at the creating a new VM inside the cluster and using Azure Bastion to connect to it. So I really wanted to use this command to connect first, but it looks like it's going to take a bit of a time to for this server to come back up. I hadn't realized that creating a private cluster meant recreating the entire cluster, which is kind of an annoyance. Another thing I forgot to mention that I had changed was the virtual network settings. So I had a virtual network over here in this virtual network resource, and its address is 10.0.0.0/16. So what that means is you're allowed this all the way up to, I think it's 255, 255, 255. So all of these IP addresses are allowed in this subnet, in this virtual network. And if I go back to the Kubernetes resource, I read all the documentation on how this content is used. And it turns out that you need to give an address space for any services, so Kubernetes services that live in your cluster. And this address space needs to live outside of the subnet. So that's why I've got 10.1 over here. The subnet itself, and then the rest of the IPs are going to be used by the node pools themselves. Also, the DNS service IP, I noticed that it has to be on the same sort of range as the service sider. And then I noticed in the docs that they all end in .10. And I only read that that is required if you're using the KubeNet instead of Azure CNI for the network. But in all the examples I saw for Azure CNI, they also had .10 on the end. So I think that may be a requirement, but it's not explicitly called out in the Azure CNI docs. It may just be a coincidence, but I'm using that there as well. So that's something to call out right there. Let's see if we manage to destroy our cluster. And we can go and have a look in, keep opening the wrong thing, in our Azure dashboard as well. And everything is still slowly being deleted. So that takes a fair amount of time, unfortunately. We'll move on anyway. So another thing that we should talk about is disabling the run command. So what you can do is this command here, you can actually disable it. And if you set up the virtual machine we talked about earlier, that might be a good thing to do from a security standpoint. So I think it's just disable run command equals true. We will leave that for now, just so that we can demo using the run command. But we'll come back to that in a moment. So let's try to create an Azure virtual machine. Let's jump right into that. Whoops. Let's go to Kubernetes and we'll create a virtual machine. And I'm just going to use the portal to help me create one. And we'll see how in a moment. So I'm going to create, I'll stick to, well, it doesn't matter what resource group, but we'll need a new resource group, but we'll create it in common for now. Just give it any old random name, North Europe, availability options. Since this is just a kind of a jump box where you're going to remote into, to be able to connect to your Kubernetes cluster. I don't think we need any of these. So no redundancy. Trusted launch virtual machines. So having a TPM would be useful. So this is all the newer processors that have TPM modules to make sure you have trusted code running in your CPU. Confidential virtual machines. Higher confidentiality and integrity guaranteed with hardware-based trust execution environment. So yeah, I don't really know much about these two options, but I'm just going to go with standard for now. We'll go with a Ubuntu server because I don't want to pay for Windows. At the end of the day, we're just going to be using the CLI here on the machine. And does it need to be a spot instance? No. And CO VM sizes, I just want whatever's the cheapest. So we'll go to B series, and it doesn't need to be a fast machine at all. B2S, B1S, 4 gigs of RAM. We'll go with a B1S for now. And authentication type, public key, username, generate a key pair name, public inbound ports, none. So we want it to be completely private, this virtual machine. Next, disk, premium SSD, standard SSD. SSD probably helps with performance. We'll go with premium, doesn't cost too much. Delete with VM. Yep, encryption at host. Can't do that for some reason. Maybe because we're using B1S VM type. Encryption at rest is fine. Data disk. Do we need a data disk? No. Advanced. Use managed disks. Networking. We need to add it into our virtual network. We have this is creating a new virtual network. We actually could just add it into the Kubernetes virtual network, and that way, oh, we're deleting, aren't we, right now? So hold on, we need to bring back our stack. So that while that's building, we'll plug into the existing virtual network. Public IP none. We don't want it to be exposed. No network security groups. Well, maybe basic, I don't know. Public inbound ports none. Okay, we'll delete that when the virtual machine is deleted. Next, management. Boot diagnostics. Guest diagnostics. Login with Azure AD. No. Yes. We can log in with our Azure account. Enable OS guest diagnostics. No. Enable auto shutdown. This is good. We could probably save a bit of money on this by shutting it down at nighttime and starting it up again. But for now, I'm just going to disable that. What does this? Does it bring it back up again? I don't know. Okay. That we're gonna have to wait for it to start up then. Guest OS patches, advanced, and host group, capacity reservation, next tags, and review and create. Okay, so this is where we can look at all of the template, the ARM template, and see if we can use this to create the virtual machine ourselves using Pulumi. So it's created a fair amount of stuff. We'll take that. We'll do file, new file, JSON, open. I'll paste that in there so we can have a look at what's in here. So we'll start out with our virtual machine, and there's a fair amount of settings here that we need for that. Virtual machines, and it depends on our network interface, hardware profile. There's a fair amount here. Oh, okay, I think I need to log in again. Excuse me for a moment while I log in. Logged in. Pulumi up initial. That should bring that up. So let's see if we can create this virtual machine. So we'll create virtual machine. There it is. So we want to create one of these, and we can take this code and see what we can create here. So I'm going to create a new resource here as well, and we're going to call this Jumpbox resource. And this needs to inherit from component resource. Oops, it has to be in the constructor. And I'm just gonna take this code and comment it out for a moment. So var virtual machine equals new virtual machine. There's our name and new virtual machine args. And we'll pass loads of stuff in here in a moment. We also need to pass a bunch of options in here. And just copy that and stick that in here. So we need a resource group. We're going to store this in location, component resource options, and this is the Jumpbox resource, and we want a nice name. So I'm just gonna rob this line of code here, give it a nice name, and in actual fact, configuration application name, and this is going to be our Jumpbox location environment, and we can start plugging in some options here. So these are the options we need. We've got VM name, we've done that already. Location, so we'll do the location equals location, tags equals get configuration dot get tags, and we'll pass the location in there as well. So we have that done. Resource group equals resource group dot name. we've done that. Storage profile, OS profile, network profile, and hardware profile are remaining. Hardware profile. Oops. New hardware profile. And that's an of type input. I'm just gonna do that and that and that. Inputs and VM size equals, this is going to be virtual machine size types. Okay, standard underscore B1S. This could be turned into a configuration setting later. How are we going with our creation of our Kubernetes cluster? Nearly there. We need to, not sure why standard is written here when I chose B2S. We did that setting. Storage profile, we can do that next. Storage profile equals new. Storage profile args. And data disks, image reference, and OS disk. So image reference equals new image reference args. And what we want here is offer equals Ubuntu server. Publisher equals canonical. SQ 1604 LTS. This is different to what I selected. I don't know why. What's going on here? Oops. I wanted 2004. So if I go to review and create, is it going to show me the right virtual machine name? Oh, that's a bug. Come on. It's thinking about it. Kubernetes cluster still trying to get built. Okay, let's go have a look at what we need to pass there. So everything's completely different. Ubuntu server focal. Standard. Yeah, that was weird. So those are the new settings. So the publisher is still canonical with the lowercase c for whatever reason. The offer is Ubuntu server focal. The SKU is this guy. And the version is latest. So that's the image reference settings done. OS disk equals new OS disk args. And we want caching to be caching types. Read write create options equals create options dot, oops, disk create option types. Disk create, not update, option types dot from image manage disks equals new manage disk parameter args, and the storage account type equals storage account type dot premium LRS location redundant storage. ZRS is zone redundant storage. We don't want zone redundant. This is just a Jumpbox. We're not going to be storing anything on it. And the name, we need to give it a name. And can we give it a name similar to this? Jumpbox OS disk. And so that's all our storage profile settings done. OS profile. And network profile. Let's see. OS profile, where does that go? OS profile equals new OS profile args. We should look at the Pulumi documentation for this as well, to see what they're doing. So they have their hardware, location, network profile, pointing at something, OS profile is very similar to what we have. Resource group name, they're using 1604 LTS. Read write from image, premium LRS. Very similar settings to what we set up actually, which is hopefully a good sign. So if I put this OS profile besides their one, your password, your username, my VM, Linux configuration, provision, VM agent, that looks the same. Okay. Admin password, admin username, computer name, oops, Jumpbox. And we want Linux configuration equals new Linux configuration args. And this is going to be patch settings. Assessment mode, image default. Equals Linux patch assessment mode image default, and provision VM agent equals true. Not sure what that does. So now we have our OS profile sorted out. We need to figure out what to do with the username and password. Obviously, we can't just set it to some random value like that. I wonder if any of these quick starts can help us. Generalized shared image. Nope. With password authentication. SSH authentication. So for this one, we only create a username to get in via SSH and disable password authentication becomes true. And that becomes an equals. So I think that's more secure. And then the username, we'll just call this, I don't know, Jumpbox again. Jumpbox user. So our cluster is created now. We can go back to trying to run some commands on it. So if we try to run this command, kubectl get nodes, we should be able to try and access the cluster. So let's go back to our dashboard, skip this, we don't need this anymore. If we go to our Kubernetes resource group, copy and paste that. And we need our cluster name as well. Where's our resources in our cluster? Maybe this dashboard hasn't updated itself yet. Here we go. This guy is what we want. And I can just go here and we can run get nodes. Does that work? The resource under resource group was not found. Name, command invoke. I wonder why that is. Oh, did I get the right resource group? Looks like there's been some stuff moving around. Why has this been created? I didn't create this, did I? I'll just delete that. That must have been created when I was trying to create the VM. Which one is it? So that has no resources. It must be this one. Okay, it looks like I just got the resource group wrong. Azure does take its time to remove things from the dashboard. kubectl get nodes. And we should see the nodes in our cluster. Yes, cool. That's awesome. AKS, so we have one system node in the first availability zone and one user node in the second one. Cool. I'll make a note of that command. And we'll carry on with our Jumpbox user. So next we need a network profile. and we want to pass in network interfaces. And what we'll do here is unclear. So copy this code, and it looks like you have to set an ID to this massive long string. No idea what that does. Primary equals true. So that creates a network interface so we can connect it to our virtual network. So we have our VM settings sorted out. Yeah, so Ajmal is asking, private cluster created, but how without DNS resolution? So yeah, so first of all, we tried the this command. So this is one way of tunneling into your Kubernetes cluster and running commands, but it's a bit cumbersome. The other way is we're going to create a virtual machine over here, and we're going to remote into that virtual machine using Azure Bastion, which we also need to create. Kube API server, FQDN, and private IP address. Yes, so the fully qualified domain name, just so I'm fully clear. So there's a fully qualified domain name that gets created for us using this setting over here, but it's pointing to a private IP address within the virtual network that the Kubernetes cluster is contained in. So it's not very useful to have it around. And oh yeah, I was going to point out what that fully qualified domain name is and where to find it. And if I remember correctly, let's go back to the documentation really quick and search for this guy. We need to find the output of what the fully qualified domain name actually was, and I can't remember off the top of my head where that setting was specified. So creating private cluster, accessing the private cluster remotely, FQDN. Was it in here? There we go. So we'll do that. Disable the public FQDN. So we don't want to disable the public FQDN. Configure private DNS zone. Is it down here? So maybe there's an output to the cluster that we can look at. Yeah, so let's have a look at the managed cluster that we create here and see if we can find private FQDN. Yeah, FQDN of the master pool. We should take that and output it. So we'll do we'll call it cube FQDN. This dot cube FQDN equals managed cluster dot FQDN. And there's a few FQDNs here, so let's kind of just review what they are all about. That's the FQDN of the master node pool. That's probably the one we want. FQDN subdomain, Azure portal FQDN. So this looks like the same FQDN as the one that points to the system node pool, but it supports cores. And private FQDN. So we don't want to use a private FQDN, we want a public one. So resource group cluster name, query, private FQDN. Yeah, we want to use the public FQDN. So if we have a private one, it's not going to be very useful to us. Well, you could use it. Well, does it matter? So there's a feature in Azure AKS. If you read this documentation, that allows us to use a public. So it doesn't really matter if the FQDN is public or private, because the cluster is private, so the IP address is internal. So private, public doesn't matter. I think I just stuck with a public one just for ease of use, really. Okay, so let's run this again and add output cube FQDN, and of course I need to make this compile, otherwise we are lost. So this now should output the FQDN value in a moment. It should be pretty quick this time because we haven't changed anything, we're just adding an output. And in actual fact, I didn't pass that output out to this guy. Cube FQDNs. Cube FQDNs. We need to do something about the output situation here later on. Cube configs, and we'll Kubernetes resources. We'll change this to a list of Kubernetes resources. And I think we can just move this in here then. What's the indentation situation here? All right, I think that's sorted out. And then this guy, we want to select .kubeconfig. And with this guy, we want to select cube FQDN. I think that's it. And what did we do here? And that we got build error because we were mucking around with the code while it was still running. This should be pretty quick. It's just building now. We can go back to our virtual machine. AAD login extensions name. This is how to log in with AAD. I guess we don't need that anymore. The output is the username. Virtual network. So this is creating a new virtual network. That's something that we could do. So if we created a new virtual network, put the Jumpbox in it, and then we would need to pair the two virtual networks together. The one with the Jumpbox, one with the Kubernetes cluster, pair them together so that they can talk to each other. And that might be something that we do going forward, because if you want, so this code is actually capable of creating multiple Kubernetes clusters in different locations. So it creates a Kubernetes cluster in every one of these locations that you specify here. So Northern Europe at the moment, I could do West US or whatever. And that would be good to have a one location where you can pair to one Jumpbox location you can log into and then access any of the clusters. So do we have, why don't we have more outputs? Did I not save? Oh, I forgot the attribute. Output attribute, that's important. So I'm just gonna save, commit this code that I've got so far. Stage that, save. Oops, don't want to save the stage that, don't save that. Stage that, don't save that. So the changes we made are mostly around the outputs. I can remove that comment. And we changed the namespaces, enabled the private clustering. I can remove that comment. We don't want to disable the run command until we have the private, the virtual machine sorted out that we can log into. Yeah, Ajmal is asking for production we should disable the public FQDN. Yeah, I suppose it would give you a very small additional set of security by obscurity. So if nobody knew what the private IP address is, if they managed to get into your cluster in the first place, they wouldn't know where to look. But I think at the point that they're into your cluster, all bets are off and you've already lost, and they can access it. So I don't think there's a problem with exposing your private IP outside to the public. It does. Did this get completed? Yes. So there's our public FQDN. And if I use, was it dnspy? dnspy. If I switch over to Alpine Linux, and I haven't used this for a while. dnspy. No, not dnspy. What am I thinking about? So let me show you something cool. I have a bash cheat sheet that's worth looking at. And oh, dig. I wanted dig, sorry. So if I just do dig and plug that in, we get our internal IP address 10.0.0.4. So this is inside our virtual network. That's our Kubernetes cluster API that we can talk to. Cool. So we managed to get that. We've got our FQDNs, we've got our kube configs. Let's finish our virtual machine, which we may not finish in this particular stream, but I will try. So we make cluster private. We'll check that in. What's going on here? Stage that change as well. Cool. So we only left with our Jumpbox resource left, which we'll embellish. And we need to create this instance in our stack. So we need to go, where do we create it? For each, we need to pass in new Jumpbox so we can give it a nice name. Configuration. So we need to pass in the virtual network into here so that we can get that connected as well. We'll pass that in here. And we'll need to connect the two, and let's have a look in the JSON file how we do that. So resources, network interface names, subnet ref, oh my god. We have network security groups here, virtual network name. So this is a virtual network. It has a subnet, and I forgot to get the values out of what these parameters, what values these parameters have, but I don't think we need them just yet. We have our virtual network is connected to our subnet somehow. Subnet ref. Our network interface here. Depends on virtual networks. NSG ID, network security group ID. I think we can ignore that. This is the bit we need. And how does the virtual machine itself connect to this? So if we go back to the virtual machine, network interfaces. Oh, okay, so that is the ID of that virtual network interface. Okay, so we need to create a virtual network interface. Let's go back to our code. Oops. var network interface equals new network interface. What? There we go. That has a name. New network interface args. And the name will be we should probably put this in its own resource group, but I'm just going to leave it here for now. Jumpbox. And this is VM. And we want this to be ID. So that makes a lot more sense now. And it looks like we've got some ambiguous references here. Network profile args. Azure Native Compute Inputs, Network Profile Args, and Azure Native Network Profile Args. Oh my god. Compute Inputs. So that comes from here. I think the network interface also has a type with the same name. If we go back to our JSON file, we want this setting here that we want, whoops, I keep doing that we want to plug in here. And this will look like something like IP configurations equals new list of IP configurations. And we'll give that a name. Oh, we need to new one up first. Doesn't seem to have a name here. Properties, subnet, here we go. Subnet equals, and then we want our virtual network resource.subnet ID. Is that right? The value of the subnet. That's terrible documentation, Microsoft. Private IP allocation method equals new. I think we can just do this dot dynamic. Cool. Input union. What is this complaining about? What is an input union? Is it? Let's bring back that code for a moment. It's just setting a property. Hybrid network IP allocation method. Oh, it's using the wrong type. The namespace situation in Pulumi is a bit overwhelming. There is namespaces for absolutely everything. We want this type. It's a bit slow here. Hybrid network. That is what we want. And that. Have we got the right type there? Did we even do the right thing here? No, we didn't. Network inputs. Subnet equal, okay, now everything's changed. ID. That's that. And of course, I think I need to just put namespaces on absolutely everything here because namespace collisions are happening all over the place. IP allocation method equals new. Oh, I can just pass this. Is that right? I got the wrong namespace. Cool. No. What namespace is it? Come on. It's thinking about it. Okay, here we go. Pulumi, Azure Network. Okay, there was no inputs on the end for reasons unknown to me. And it's suggesting I can just remove that altogether. All right. We now have, well, now this is complaining. Okay, we have a really bad namespace situation. I'm going to get rid of that namespace for the network and make that explicit for everything. And then the namespace collisions should go away. No? Hybrid network thing can go away as well. And now I've lost, what have I lost now? Then I don't need this, that's good. And we're back to normal, and I just need to validate some of these types that are being passed in over here. And I'm just going to copy and paste some code to validate these arguments passed into the constructor. We don't have an identity resource, we don't have a common resource. We can remove those two, and the rest is all good. Cool. I think that is enough now to create our Jumpbox resource. Once we've done this, we need to be able to log into it. So we do need to create a bastion, an Azure Bastion service. So let's go and have a look at how to do that. And Bastion host. This one should be pretty quick to create. I'm going to copy and paste that code and paste it in there. And this will let us log into our Jumpbox virtual machine without the Jumpbox virtual machine being public. So it's going to be totally private within that virtual network. New Bastion host. Oh man, I'm gonna have to add the full namespaces here as well. Oh man, okay. New in Bastion host args. Luckily the naming is not too long. I'm gonna take that name and call it Bastion host. And we also need IP configurations and a resource group. Oops, what did I click on? We also need tags. We need the resource group name. Do we also have location? Yes, we do. Not sure why it was not in the previous one. What's it complaining about? Bastion host equals that. Next we need IP configurations, and I think I can just copy and paste it from here somewhere. So this is network inputs, network interface IP configuration args to Bastion host. Oh my god, it's slightly different type here. This is a Bastion host IP configuration args. And are we getting closer? Sub resource args. That's one of those. And public IP address, pip name. Okay. subnet. We don't need this. I think that's it. I think that's it. I think that's all that's required. Do you need a public IP address? I'm not really sure, because in all the examples I've seen is people logging in from the Azure portal. Let's see what happens when we try to create it. So add Jumpbox. Let's give that a go. If this doesn't go too well, we will jump off to, we'll carry on with this in the next stream. Maybe I will try and get it finished before then, and we can talk about, the plan for the next stream is to talk about configuring networking, load balancers. So there's a bunch of things around load balancers and port exhaustion that you have to be careful about. And I think if you have applications which make a lot of outbound connections, it's very easy to exhaust the number of ports you have available on your node. So that's something to watch out for. We're going to make that configurable so you can set the number of ports you need. I think that's a pretty important setting to be able to set up. We have some exceptions. Resource group name is required but was not given a value. Network interface args. Oh, we didn't pass some pretty important information. So we'll stick that there. Resource group name equals that, and tags equals configuration dot get tags and location. Done. Give this one more go. So we have 3 new resources in here. We have a network interface that connects to our virtual network subnet. We have our virtual machine itself, which makes use of the virtual network interface, and it's also contained within the same resource group. And then we have our bastion host, which is also contained within the same subnet as well. Ajmal is asking, do we have plans for showing code deployments using Pulumi as well? And in an earlier stream, I actually showed that off. And it did work. But I realized that there was a bit of a problem with it working correctly. And the reason for that is, I think it's to do with Azure Active Directory. So in a previous stream, I was using Azure Container Apps, and I was able to deploy that using GitHub and GitHub Actions. But when you're doing Kubernetes, you need to create this identity stuff around an Azure Active Directory application and service principal and so on and so forth. And you just don't have permissions to do that using the default settings when you're setting up GitHub Actions and all the service principles and everything. So that's something I've been trying to fix. I've actually asked a Stack Overflow question around that, and it's not straightforward, but I'm trying to get it sorted, and then I'll share on the stream how I got that working. So this failed again. This time we got bastion host IP configuration args. Public IP address is required but was not given a value. Okay, so we need a public IP address. Interesting. All right. If we go back here, public IP address, we need to create a public IP network public IP address. We'll create one of those, and we'll stick was it? Where was it? Public, nope. Public IP address equals new. I need the namespace, don't I? And ID equals, and then we're going to create a new public IP, and we'll just copy and paste that. So this is the public IP for the Bastion host. I wonder if I can just modify this. Is that going to require we'll give that a name, new public IP address args, and then these are the settings that live in here, and equals, we switch that to equals sign, capital L, switching this from TypeScript. Public IP address name, I think we don't need that. Resource group name, I think we can copy and paste this bit of code here, paste that in here, and DNS settings is of type public IP address DNS settings args, new public IP address DNS settings args, and we don't want that namespace that it added for us. Where did it go? There it is. Domain name label. What is this? Domain name label. We don't need this. Why are we setting DNS? I think we can just get rid of that. This is var ID. Cool. I think that's it. We should probably set a SKU on here as well. SKU, no. DNS name, ID. Last try before we end the stream. In the meantime, do like and subscribe, or follow if you're watching on Twitch. And if you want to have a chat, give me a shout on Twitter. And you can also contact me at rehansade.com. There's a link to my email address just at the top of the page. Let's see how this goes. Any second now we're going to get an answer. It's just building right now. Yep, we are available on Twitch. I don't treat it as a first-class citizen. Probably should. I mainly focus on the YouTube just because I think that's where all the viewers are at the moment, and I think Twitch is going downhill slightly, but I could be wrong. Provisioning state tags type URN. There's no outputs for a Bastion host. 2 created. Cannot parse the request. That's odd. Update failed. Cannot parse the request. So if I go to Azure really quick, have a look at our resources, refresh them. Did it create a Bastion host? I don't see it. Looks like it created a public IP and a network interface and then failed. Or it tried to create a Bastion host. Also, this is what it was. This is the preview and this is the actual, and then it failed. Okay, so maybe I need to run it one more time. I will leave this for this stream, and in the next stream I will get this working and show it off. We'll talk more about the load balancers, and maybe we'll have a look at some of the monitoring and logging capabilities of AKS as well, if I ever got round to doing that piece of reading. So that's it for now. I think we're coming to close to finishing setting up a productionized Kubernetes cluster and then finally being able to run something on it. So thanks everyone for watching.